All right, I'm going to start recording us, and we are going to move forward with our notes for today. If you did not have a chance to get all the way done practicing labeling the unit circle, please make use of whichever link worked best for you. If it did not work here, I've provided this link. I'm going to continue to try to provide some different exercises that you guys can use to get better and faster at labeling the unit circle, especially since we're not together in class. But I am going to move forward with our notes. So this idea right here was part of the notes in the second video yesterday. So if I'm talking about an angle in standard position on the rectangular coordinate system, and there is some point on the terminal side of theta, then the distance from the origin, that's what this O is, the distance from the origin to the point on the terminal side we are going to call R for radius. Fix this real quick. So if I call R the radius, the distance from the origin to that point on the terminal side, then we have some different ways of defining our 6 trigonometric functions. Does anybody remember from the video yesterday how we can define the sine function? What is another way that we can define our sine function in terms of x, y, and r? Here I've got x and I've got y. Anybody remember how I can define sine in terms of x, y, and r? This was in the second video. Yes, absolutely correct, Olivia. This is y over r. What about cosine?
X over R.
X over r. And so tangent would be what?
Y over X.
Y over X. And then for my reciprocal functions, we're just going to take those and switch them around. So R over Y for cosecant, X over Y for secant, and that means cotangent, sorry, X over R, R over X. Oh my goodness. There we go, reciprocals. Oh my goodness, I feel so much better today than yesterday. However, I've been saying some absolutely crazy things. What would my cotangent be then? What would my cotangent be? X over Y. Yes. Love it, love it, love it. Okay. And the reason for this again, watch the second video from yesterday if you need to see one more time what's going on here. But if I have my circle, I'm going to have to recenter that guy. And I look at my angle in standard position, this distance right here, if I am in standard position, so theta is here, this would be my adjacent side, this would be my radius, and this would be my opposite side. So you can see that that corresponds to y, my adjacent side corresponds to x, and then we have our radius there. So that's why we can define it in these ways. I want to do a little bit of practice with you. Since I wasn't here yesterday, I want to talk about the signs of the trigonometric functions. I want to fill in the unit circle with you. And then we're going to do just a little bit of practice before we get into some proofs. So when we're talking about our trigonometric functions, all my trig functions are positive over here in quadrant 1. Which trig functions are positive in quad 2? Which trig functions would be positive in quad 2? Are my x's positive? Are my y's positive? Are they both positive? Remember, the radius of our circle is always going to be positive. Let's fill in our unit circle and we'll come back to the signs. 0 degrees, 30 degrees, 45, 60, 90 degrees up at the top. Yes, Justin, X is negative, Y is positive. So let's get our degrees filled in, and then we'll look at how that affects which trig functions would be positive. Oh, I wrote 210 and I meant to write 120. I transposed my numbers up here. 120, 135, 150, 210 is down here. 225, 240, 270, 300, 315, 330, and 360 degrees. We want to be able to do our radians as well. 0 radians, pi over 6, pi over 4, pi over 3, pi over 2, 2 pi over 3, 3 pi over 4, 5 pi over 6, pi, 7 pi over 6, 5 pi over 4, 4 pi over 3, 3 pi over 2, 5 pi over 3, 7 pi over 4, 11 pi over 6, and 2 pi. And then you guys did add the ordered pairs yesterday, or you should have. If you did not, please make sure that you go in and get those. 1, 0. This over here would be square root of 3 over 2 and 1/2. Square root of 2 over 2, square root of 2 over 2, 1/2, square root of 3 over 2. These are coming from our special rights, our 30, 60, 90s, and our 45, 45, 90s. Up at the top, I'm at 1, 0. Over in the second quadrant, I have negative x's, but positive y's. So negative 1/2 root 3 over 2, negative root 2 over 2, positive root 2 over 2, negative root 3 over 2, positive 1/2, and then over here, negative 1, 0. Down in my third quadrant, both the x's and the y's are negative. So I'd have negative root 3 over 2, negative 1/2, negative root 2 over 2, negative root 2 over 2, negative 1/2, negative root 3 over 2. I come down to the bottom and we're at negative 1, 0. And then in the fourth quadrant, my x's are positive, my y's are negative. So positive 1/2, negative root 3 over 2, positive root 2 over 2, negative root 2 over 2, positive root 3 over 2, negative 1/2. All right, so let's look at our four quadrants. For sine, that's my y. For cosine, that's my x. And for tangent, y over x, these are all positive. Because all my coordinates are positive. So in quadrant 1, all my trig functions are positive. In quadrant 2, we have negative x's and positive y's. So if my sine is my y, cosine is my x, and tangent is y over x, which of those would be positive over in the second quadrant? If x is negative, my y is positive. Which of those three, if it's more than one, give me more than one, which of those are going to be positive in the second quadrant? Sine is going to be positive. Absolutely correct, Priest. Sine is positive. So in my second quadrant, sine is positive. What about in the third quadrant? Sine is my y. Cosine is my x. Tangent is y over x. What is going to be positive down in the third quadrant? Tangent. Negative divided by a negative is going to give me a positive. So tangent is going to be positive down here. And what about in the fourth quadrant? Sine, cosine, tangent. What is going to be positive? In the fourth quadrant. Cosine, yes. Cosine will be positive down here. Remembering which trig functions, and obviously their reciprocals, are going to be positive in those same quadrants as well. Remembering which quadrants have positive trigonometric function values is going to be really, really important. So there's some acronyms that you can use to remember. You can say all students take calculus. We have all of our trig functions in the first quadrant: sine, tangent, cosine. Moving counterclockwise around your unit circle through those four quadrants. All right. We want to find the trig function values of an angle that is in standard position if P is -2, sorry, if P is -2, 5. What quadrant are we going to be in for this right here? Where will our point P be? What quadrant? We're going to be in the third quadrant, yes. So -2, -5, something like this. I want to take that and I want to make a reference triangle. I'm going to draw to the x-axis. I'm going to put in my right angle. This side right here would be -2. This side over here is going to be -5. How can I now find the radius? What can I use to find the radius? Pythagorean theorem, yes. A squared plus b squared equals c squared, or in this case, it's going to be x squared plus y squared equals r squared. So I'm going to have -2 squared plus -5 squared equals r squared. 4 plus 25 equals r squared. 29 is equal to r squared. So when I take a square root of both sides, my r value is the square root of 29. Depending on what quadrant you're in, you're going to have to be very, very careful if you are looking for the x or the y value. Now that I know the radius there is the square root of 29, I can write my 6 trig values, my 6 trig functions. Sine of theta is going to be y over r. So what will my sine value be? What will my sine value be?
Is it -5 over the square root of 29?
Yes. -5 over the square root of 29. We're going to need to rationalize that denominator. And so with a rationalized denominator, I would have -5 square root of 29 over 29. What would my sine value be? What would my sine value be? X over R. What is my sine value?
You mean cosine?
Oh, yes, I'm so sorry. Cosine. Thank you for correcting me, Logan. What is my cosine value?
-2 over the square root of 29.
Yep, -2 over the square root of 29. Rationalize that denominator again. So I would have -2 square root of 29 over 29. When you guys do the homework in Canvas, it is the expectation that you are rationalizing that denominator. Tangent. Before you tell me the tangent value, we are in the third quadrant. So what do you know about the tangent value? What type of number are we going to get?
Positive.
Absolutely correct. Third quadrant, tangent is positive. What will our tangent value be? Five over 2, yes. And then from here, we can get our reciprocals. What is the reciprocal of sine?
Secant.
Close. Remember, every pair has to have a co with it. So this would be our cosecant. Every reciprocal pair has to have a co. That's the only way I was ever able to remember. Oops, I put that on the wrong one. So sine and cosecant go together. Cosine and secant go together. And tangent and cotangent go together. So we're going to have r over y. So square root of 29 negative square root of 29 over 5. R over x. I'm going to have negative square root of 29 over 2. And cotangent would be 2/5. Every reciprocal pair has to have a co. I want to look really briefly at one of the problems on the next screen that I'm going to put up. We're going to look just at, let's see, which one do I want to do? Let's look at just at part A. Let's start off by, which quadrant are we in? Which quadrant would we be in on part A? Two. Tells me right here, I see that I have a negative tangent value, but sine is positive. Sine is positive in the second quadrant. All are positive in the first quadrant. So if I have a negative tangent value and a positive sine value, I've got to be in the second quadrant. So I'm going to draw my reference triangle then. Tangent is what over what? I know that it's negative 3/4 here. But when I'm talking about x, y, and r, tangent is what over what? In x, y, and r, tangent is what over what? Y over x, thank you. So y over x. Do I want to put the negative with the y or the x part here? It's negative 3/4. I'm going to label my triangle. I need to know where the negative's going. Does it go with the y or with the x? If I'm over in the second quadrant, are the y's positive or negative over here? There you go. Yep. So we're going to put the negative with the x because in the second quadrant, my x's are negative. So that means along here, I have -4. And over here, which is my y, I have a +3. Pythagorean theorem to find our radius, a squared plus b squared equals c squared, or x squared plus y squared equals r squared. So I'm going to do -4 squared plus 3 squared equals r squared. 16 plus 9 equals r squared. What is the radius?
Five.
5, yes. 5 is equal to my radius. And now I have all the information that I need to do my 6 trig functions. We already have tangent, but now I can do sine and cosine as well. What would sine of theta be? What will sine of theta be? 3/5, yes. What about cosine? What's our cosine going to be?
-4/5.
Yes, -4/5. And then we need our reciprocals. What's the reciprocal of sine again?
Cosecant.
Cosecant. Remember, every reciprocal pair needs a co. Cosecant would be 5/3. Reciprocal of cosine?
Secant.
Secant. Secant of theta is going to be -5/4. And then cotangent will be -4/3. So that we have y over r, x over r, y over x, r over y, r over x, and x over y. Remembering those relationships with x, y, and r are really, really, really important. I want to spend our last little bit of time looking at the tangent identity and the Pythagorean identities. So our tangent identity was that tangent theta equals sine theta over cosine theta. So I'm going to leave the left-hand side alone, and we're just going to look at the right-hand side. In terms of x, y, and r, sine theta is equal to what with x, y, and r? What we were just talking about. Sine theta with X, Y, and R. Skip back a screen. In terms of X, Y, and R, sine theta is what?
Y over R.
Y over R, yes. And cosine theta is what?
X over R.
X over R. So I can rewrite sine theta as Y over R, and I can rewrite cosine theta as X over R. So I've rewritten the right-hand side here, not touching the left-hand side at all. I have a compound fraction here. When you have a fraction in the denominator, what do you do with it? Or what can you do with it?
You can set it up as like a division
Yes,
equation and then do it as multiplying the reciprocal.
absolutely. We are going to multiply by the reciprocal. So I would have Y over R still there. Multiplying by the reciprocal would be R over X. What happens when I multiply those together?
It equals Y over X.
Yes. We get Y over X, which would be the same thing as my opposite side over my adjacent side. That is the definition of tangent. So that is why tangent is sine over cosine. And then we have Pythagorean identities, sine squared theta plus cosine squared theta is equal to 1. I can take sine and rewrite it as Y over R. And then we are going to square it. I can take cosine theta and rewrite it as X over R. And then we square it. In my unit circle, what is R, my radius, equal to? In the unit circle, what is the radius equal to? Anybody remember? Think about the ordered pairs around the unit circle. How far out do we go in any direction? What are my ordered pairs here? One. Yeah. 1, 0, 0, 1, -1, 0, 0, -1. So in my unit circle, the radius is 1. So I can replace the r here with a 1. So I would have y over 1 squared plus x over 1 squared equals 1. So that would give me y squared plus x squared equals 1. And that is true in my unit circle. That is a squared plus b squared equals c squared. This is my hypotenuse, which is the same as the radius of my unit circle. So I want to look at a couple of problems where we're going to simplify. We'll keep doing this tomorrow, but I want to start this today with our last couple minutes. We want to use our different identities. We have reciprocal identities. We have tangent and cotangent identities, and then we have Pythagorean identities. We want to use those to simplify these different expressions. One of the hints that I have for you write everything in terms of sine and cosine. So here I have cosine x, and that's being multiplied to tangent. Can I rewrite tangent in terms of sine and cosine? Can I rewrite tangent in terms of sine and cosine? I know the tangent of theta is y over x, sine over cosine, yes. Tangent of theta is equal to sine theta over cosine theta. So I'm going to rewrite this as sine x over cosine x. When I multiply these together, what happens? What happens when I multiply these two together?
The cosine cancels out.
Cosine cancels out. And so what would this whole thing simplify to give me then?
Sine x.
Sine x. Yes. We're going to continue practicing with simplifying tomorrow. You guys do have a homework assignment due for me tonight. It is the 6.2 part B, right down here. Hopefully you got a start on it yesterday. If not, work on it tonight. There are 13 questions there. Goes along with the video and what we spent the majority of class today working on. Please let me know if you guys have any questions about that homework. Send me messages in Canvas. It is completely automatically graded and you have an unlimited number of attempts at it. So please let me know if you guys run into any problems. We'll keep simplifying and then we'll learn how to verify tomorrow as well. I hope you guys have a fantastic rest of your day and I will see you tomorrow.